Everyone, and welcome to lesson 12.3. Today we are going to talk about permutation and combinations. And what is exactly the difference between our permutations and our combinations? Well, our permutations are the number of ways we can arrange things where order matters, as in lists or placements of that way, where combinations are the number of ways we can choose things. It's just a group, order doesn't matter on those. So again, if we're looking more at some specific examples, permutations is where we're looking for something like who's the team captain or co-captain, who is going to be the pitcher, the shortstop, who's batting first, second, third. What is the ranking, first, second, third on that? The winners of a race versus when you're just picking people to be on a team or to form a group, colors in no specific order that you just are picking, or three winners, but the placement of those winners doesn't matter. They're winning as a group. So there are specific ways to compute these using the factorial button. But also, our calculators have the ability to do this, which we will discuss a little bit later, to pick our groups. So, first and foremost, similar to mutually exclusive and non mutually exclusive, we want to be able to determine what type of situation do we have each time. Is this going to be a permutation or a combination? So, in these first examples, we have a student body of 30 students and they just want to elect four representatives. So, it's not specific ranking of who's the president or the treasurer, but just a group of people that we are going to pick. That's going to be a combination. In a group of 20 people, they're going to run a race. Top three runners get gold, silver, and bronze medals. That is going to be one of our permutations because the order, the placement mattered, who got what medal. In number three, if we have a student body of 25 students and they want to elect the president and the vice president, that again is a permutation because the order mattered, right? Having a president versus the vice president, the order mattered, who came first, who came second. And then the last one, a team of 14 field hockey players, and they need to choose three players to refill the water cooler. Well, that's just going to be a combination because you're just picking a group of people to do a task together. The order is not important. You just had to pick three from the 14 combination. So there are two for you to try at the bottom. You have a batting order of 7 players on a 12-person team, and then the 35 applicants to fill 3 software tester positions. All right, on the next page, we are discussing then how to actually compute these different combinations and permutations. So for our graphing calculators, if you go under the math menu and scroll over to the probability portion here, you see that option 2 is for your permutations, option 3 is for the combinations, and when you are in our normal print or math print here, mode. If you're in the math print and we are selecting that, um, again, the underneath the math menu, and we again scroll over probability, you'll be able to just type in when we select, for instance, the permutation, option 2, you'll type this in just as so, which we'll explain in a minute. When you are not in math print mode, or if you have a non-graphing calculator, yours is going to show up a little differently. So when you choose, you're going to plug your first number in first, and then you are going to select your probability. So let's say you're selecting option 3 for a combination, and then type your second number, okay, for the non-math print mode. On a non-graphing calculator, that's going to be located under the PRB menu. You will find your combinations and permutations. Okay, now let's actually work on calculating those. So on the first example, we have Michaela, and she has homework in 7 subjects, and she's deciding what order to complete them. So on this first one, this is actually going to be a permutation because she wants order on this one. That's an important piece of the puzzle, what order she completes. So she has 7 subjects and she's choosing to all 7 of them, but again, the order is going to matter. So we're going to type in 7, and again, we're going to go for graphing calculator underneath the probability menu, select option 2, and we are going to then choose those 7 things, and there are 5,000 40 ways in which she could complete those 7 assignments. And the second one, Emily and Ming are planning trips to 2 countries this year, and there are 5 countries they would like to visit. They're trying to decide which ones to skip. Well, order's not super important. They're just choosing which 2. So this is going to be a combination. So we have 5 options, and we're going to choose 2 of them. So again, we're going to type this in 5, and then we are going to select from the probability menu, option 3 here, and we're choosing 2 of them. So there are 10 different combinations that they could have on that. Number 3, there are 35 applicants for 3 jobs: the computer programmer, software tester, and manager. Now, these are 3 different jobs, right? They're not all the same exact job. So we have to be careful because the order is important. This is a permutation, who specifically gets what job. So we have 35 applicants. And again, because it's a permutation, and we are choosing to fill those 3 roles out of those 35. So we're going to type the 35, math menu, and then again, option 2 this time. And we're choosing again 3 roles. So 35 people choosing 3. There are 39,270 different permutations for that. Different ways we can order it. All right, number 4, we are setting the combination on a 5-digit lock. You want to use the numbers 3, 8, 1, 7, and 5. Well, on a lock, order ends up being important, right? Where each of these 5 numbers come is very specific because that's the way you need to enter them to unlock your lock. So this again is going to be a permutation because of that order. We have 5 numbers. Order is important, but we're still choosing all 5, right? So 5, and then again, math menu, scroll probability or PRB, choose 5. There are 120 different combinations to be made. Number 5, we are selecting 8 players that will be in the batting order for our 11-person team. So we're basically just picking 11 people. Order right now isn't specific. We're just picking them who will be in it, right? That one is going to just be a combination because we need to select which 11 out of the 11 are going to make the actual batting lineup. So that is 11. Order not important here, so we're checking the combination, picking 8 of those, and there's 165 combinations. Now, the second part is very similar, but notice it's specific to not just who will be in it, but the true batting order, right? Who's pitching first versus who's in the cleanup spot. So batting order is important, not just who you're putting in the lineup. So the permutation here, then we have 11 players, and we're choosing 9 of them this time. So 11, and we're going to select a permutation because we care about the order this time. Choosing 9. There is over 19 million different combinations we can have, permutations, order mattering here for this lineup. All right, there are 3 for you then to try at the bottom. Again, always make sure you decide, is it a combination or permutation first. First one, you have a group of 20 people running a race. Top 5 finishers are going to the finals. Number 2, a team of 13 field hockey players needs to choose a captain and a co-captain. And then the student body of 205 students want to select 2 representatives. Thanks everyone for watching. We'll work more in class.